Alrighty, so this will be our final exam review. Uh, as usual, the test will be online for this semester. It will be posted to Canvas just like the previous exams were. The only difference being that this being the final exam will be worth twice as much. That is, it'll have twice as many questions, I should say. Twice as many questions you could expect. It'll take twice as long as a normal exam. Usually the exams are about an hour, so this should be a 2-hour exam. However, this won't be timed. You'll have the whole day to work on it on your exam day. So just as before, I will post the exam to Canvas in the morning, download it, work out showing all your work. Then you go back, submit it back to Canvas by 11:59 p.m. Definitely be sure to submit early. I cannot accept late final exams. You can't take the final exam the following day, nothing like that. So be sure that if you're having any issues, you let me know as soon as possible so we can handle the issues. But download it in the morning as soon as you can. Make sure you get it, work it out, and try to submit it as quickly as possible. You shouldn't take the whole day. It's a 2-hour exam, but you have some leeway into when you want to start it, depending on what your schedule is. This is cumulative, so I'm about to go through what topics we've covered over the course of the semester, just to kind of give you a little refresher about what we've covered and what we haven't. But note, best way to study for this final exam is go back through all the tests we've taken and redo them. Try to do them on a blank sheet of paper. If you could do well on the tests, you're going to do well on the final exam. And the reason is because if I thought the questions were important enough to put on an exam, then those are the same types of questions that will be important enough to put on the final exam. So if you can handle the test questions, the final exam questions will be very similar. Not exact, but similar questions. Once you've done that, go through the homework problems, go through the practice problems. Work out as much as you can, especially those that you're having trouble with. Get as much practice as you possibly can. And of course, if you have any questions before the final exam, feel free to email me. But the topics. So from the first exam, we covered thermodynamics. And with thermodynamics, what did we have? We had calorimetry. Those were the questions that had to do, like Q equals Cm delta T, or Q equals M times L. These were, you put a bunch of objects into a system, all at different temperatures. What will the final temperature of the system be? If you remember those types of questions. We also had conduction problems. So heat transfer through conduction, that was the heat transfer rate. Moving through a system is K A delta T over L. So you have a wall of a certain thickness and it's got a certain size. The conductivity is 200, and the temperature on one side of the wall is 100 degrees, on the other side of the wall is 0 degrees. I want to know how much heat transfers through the wall per second, or how much heat will transfer in 1 hour, those types of questions. Those were heat conduction questions. We also had radiation. Radiation questions, similarly, had to do with heat transfer. So how much heat is transmitted by an object that's radiating heat due to its temperature. It's sigma epsilon a t to the fourth. So of course, any of these constants like sigma or specific heat or things like this, they're going to be given on the test, so you don't have to memorize them. Epsilon, that was the emissivity, so how well does the object radiate? Is it a perfect radiator, or does it radiate at 75%? A is the surface area, and T, of course, is temperature. Remembering that for all of this thermodynamic stuff, if I'm asking for the temperature, it has to be in Kelvin. If I just need the change in temperature, or delta T, then you're allowed to use either Kelvin or Celsius. So just make sure you have the right units. And then lastly, we had things like P1, V1 over T1. It's P2, V2 over T2. So all of the questions I had to do, Boyle's law and Charles' law. The pressure of an object is such and such, and its volume is whatever, and then I change the pressure to this, what's its new volume? And that related to, of course, the ideal gas law, which was PV equals nRT. So these were all the topics we had that had to do with thermodynamics. So obviously, this is 1, 2, 3, 4, 5 different topics under this specific topic. Since we're going to have about twice as many questions, that means you can expect maybe about 12 questions on the final exam. I'm probably not going to be able to put a question from every topic. But, of course, you don't know which ones I'm going to choose, so you have to be prepared for them all. But just know, likely, we may have 20 topics, but only 12 questions to work with. Okay? But these were all the topics we covered in thermodynamics this semester, so these are the things you should concentrate on. And like I said, look over exam 1 to get a sense of the types of questions that were covered for thermodynamics. The next exam covered, I believe it was fluids. And with fluids, we had, again, a few different topics. One topic we had was Bernoulli. And that was P1 plus rho GH1 plus 1/2 rho V1 squared is the same for the second location. These were the types of questions where you have some pipe system, and a pipe can change, it can go up, it can go down, it can get bigger or smaller, and you want to know how the pressure changes. Along with it, you get the continuity equation, which tells you if the pipe changes size, how does the velocity change? So that was A1, B1 is A2, B2. Okay, so those were the Bernoulli style equations. We also had pressure depth relationships. And so that was the pressure at a certain location or at a certain depth is given by rho times G times H, where H is the depth. How deep do you go in the water? And remember the difference between gauge pressure versus absolute pressure. Gauge pressure is how much does the pressure change. Absolute pressure is how much does it change plus the initial atmospheric pressure. All right, we had the percent submerged style. So a ship is placed in water. 30% of the ship is under the water, what's the density of the ship? And so you get percent submerged or fraction submerged if so that's submerged would be the density of the object over the density of the fluid. Right? If 20% of the ship is under the water, then the density of a ship should be 20% of the density of the water. From there, we also had buoyant force, so Archimedes' principle. And Archimedes' principle had several relationships, like the volume of the object submerged is equal to the volume of the fluid, which is displaced. The buoyant force is given by the weight of the fluid displaced. And so the buoyant force is rho fluid volume object times gravity. So these were, what's the buoyant force acting on an object? Or what's the apparent weight of an object which is under the water? Things like this. And so these were all of the fluid style questions. Last topic, and those of course would be covered on exam 2. Last topic is optics. And this was our latest exam, which is exam 3. And with this, we had several topics, of course. We had the wave function, or the mathematical function of a wave. That was y is equal to a sine kx minus omega t. So being able to know what are the different characteristics of the wave by looking at its mathematical form, or given the characteristics, can you write down the mathematical form? We had polarization. Which was the law of Malus. That's that intensity is the initial intensity times the square of the cosine of the angle. And so you can have number of polarizers in a system. You send light through and you want to know how much light comes out the other side. And so for each polarizer, you get a cosine squared. Refraction. Here we had Snell's law, which is n1 sine theta 1 is n2 sine theta 2. Light coming from the air hits the surface of water. What's the angle inside of the water? Because the light will bend. Also critical angle, which is the special case of when light goes from a dense medium to a rare medium. It doesn't leave the dense medium, but it skims the surface or bounces back. Total internal reflection. That was critical angle. So again, you use Snell's law, but the special case is at the critical angle, theta 2 is 90 degrees. So you solve for theta 1. And then we had imaging. Imaging problems, of course, involved lenses and mirrors. And for these, we use the imaging equation. 1 over f is 1 over do plus 1 over di. F, focal length, do is object distance, di is image distance. So an object is placed this far away from a lens. Where will the image be formed? And then, is that image real or virtual? Magnification minus di over do. So once you know where the image is, you can calculate what will the magnification be. Will the image be bigger than the original object or smaller? And so you can tell that by when you calculate the magnification, if the number, the absolute value, the number itself is bigger than 1, it's magnified. If it's less than 1, it's minimized. And then if it's positive number, it's upright, it's pointing in the same direction as the object. And if it's negative, then it's inverted, it's upside down. And so those were the optics topics. And these, of course, as I said, are covered in exam 3. So as you can see, there are 3 overall big topics, but under those topics are a number of subtopics. So there's 4 for optics, there's 5 for fluids, and there's 5 for thermodynamics. So 5, 5, and 4, that's 14. So as I said, there's more topics than there are the number of questions. So, I'm going to have to pick and choose which are the most important in my mind, or which are the ones that won't take too long, things like this. But you're, of course, responsible for every topic. I can't say, oh, don't study this one or don't study that one. You need to study them all. And you have the resources to do it. You have your former tests, you have the homework, and you have the practice problems with the solutions. There's a heck of a lot of example problems to work on. Work on the test, do it all over again with a blank sheet of paper, see how well you do. The questions you're getting right, good, you're good with them. Concentrate on the ones you're getting wrong. From there, go to the homework problems or the practice problems and do a few more practice problems on those particular styles of questions and check yourself with the solutions and see what's going on. Don't be afraid to use YouTube and outside resources to find other people doing example problems and see how they do them. But I promise you, if you do well on the first 3 exams of the semester, then you're going to do perfectly well for the final exam. It's the same type of questions, same feel of a test. It's just there's more questions here since it's cumulative. So anyway, I will be emailing everybody, of course, to remind you when the final exam is and when the test is posted. Definitely be ready to take it. You need to have the ability to take it. You'll have the whole day to submit it, and you need to get it in time. You need to submit it before the deadline is over, because I'm not going to accept any late submissions on a final exam. So anyway, other than that, I wish you luck with the studies, and I'll see you next time.